Good day, viewers all over the world. So we are welcome to today's revision class, which happens to be the last revision that we're going to do before your examination. This will be the last revision that we're going to do before your examination this morning. So I'll be starting with circle geometry. Please just comment at the comment section if I'm audible. If you can hear what I'm saying, just let me know if I'm audible. Let me know if I'm audible. Please just type. Let me know if you can hear what I'm saying. If you can hear what I'm saying, just type. Let me know so that I can start the class properly. Can I continue? Okay. Thank you. So let's start the class. We have a lot of work to do. So I'll be starting with circle geometry. So I'm going to recall. I'm going to recall some of the theorems that we have in circle geometry before we treat examples. So this will be the final revision that we do. We are going to do it up to 6 a.m. Then you can just go and take your bath and prepare for the examination. So circle geometry. The first theorem that we are going to consider under circle geometry, the first theorem is the theorem that has to do with chord. Okay, that theorem states that. Of course, before I go into that, let me talk about the property of a circle. Let me just do a recap on property of a circle. If this is a circle, the circle have a center. This is called the center of a circle. Okay, if I want to draw a circle, I'm going to use compass. So this is the center of a circle. A line drawn from the center of the circle to any part of the circumference. Any part of the circumference is called radius. A line drawn from the center of a circle to any part of the circumference is called radius. Then you can also have another radius in this direction. This is another radius. So a line that divides the circle into 3 equal halves is called diameter. Diameter divides the circle into 3 equal halves. Then in the diameter, there are 2 radii. There are 2 radii in the diameter. So radius is the same thing as diameter divided by 2. Please let's note. So this is the circumference. This circular line is called the circumference. It's called the circumference of the circle. Okay, so please let's note that in the diameter is equal to 2 radii. So if you want to find the radius of the circle, it's diameter divided by 2. So that's that about. This is called diameter. This is called diameter. Okay, so we can also have another straight line. That touches the 2 points on the circumference, but that straight line does not pass through the center. Then that straight line is called chord. So we can say that a diameter is a chord, but a chord is not a diameter. Please let's get it right. A diameter is a chord, but a chord is not a diameter. In case of a diameter, it touches the 2 points on the circumference. A chord also touches the 2 points on the circumference, but the diameter passes through the center, but the chord does not pass through the center. So a diameter is a chord, but a chord is not a diameter. So that's that about that. So then not only that, this chord divide the circle into two segments. The upper one here, I want us to get something right here. This chord performs 2 functions. It divides the circle, so that is this line, this circular line, plus enclose what you have there into 2 segments. The upper one, the bigger one, is called the major segment. This is called the major segment. Then this one is called the minor segment. Okay, the chord divides the circle into 2 segments, major segment and minor segment. That's one function of a chord. Not only that, the chord also divides the circumference of a circle into major arc, and minor arc. So arc is just this line. This is the minor arc. This line here is the minor arc. The upper one is called the major arc. Okay, it's called the major arc. So let's know that. Apart from that, before I go into the circle theorem, I just want to do a kind of recap so that when you see a question on this, you know what to do. Not only that, if you have this chord now, this is the chord. A line from the center of the circle to any part of the circumference, we said it is called radius. That line is called radius. Okay, the line is called radius. If this center 0, if I have another radius here, okay, this is another radius. Then if I bring out, let's say this is AB, this the chord. Let's give the chord a name, AB. The chord is AB. So if I bring out this sector now, if I bring out what you have here, it's called sector. What I have here is called sector. Okay, if I bring what I have here, this is 0, AB. So in a sector, you have a triangle, and you have a triangle, and you have this chord. This is the chord. Then you have this minor segment. So if I bring out the sector, this one is called a sector. All this diagram, everything that I brought out from here is called a sector. In a sector comprises of two things. In a sector, we have a triangle. This one is called the upper. This upper one is called triangle. Then we have a segment. So in a sector, sector consists of a triangle plus a segment. That's what you get in a sector. So please, I want us to know something. I'm trying to drive at something at the point now. Let's say this angle is theta. This is r. These are some of the things you do. You can be asked to find the length of an arc. So what is the formula to find the length? If you want to find the length of an arc, this arc, this is the arc AB. The length of arc AB, the length of an arc by formula is given as theta 1 over 360 degrees multiplied by 2 pi r. This is the formula that you use to find the length of an arc. For instance, if you say, you can get the question, when you check past question, you must have come across this. Say, you can say, once you are given theta, that's an angle. You are given radius. Of course, pi is a constant. Pi is equal to 22 1 over 7 or 3.142. It's a constant. So this is the formula to find the length of an arc. Okay. So apart from length of an arc, we can talk about perimeter of sector. This is a sector. In a sector, this is one radii, this is another radii, then we have a length of an arc here. So we can be asked to find the perimeter of sector. By formula, perimeter of sector is how many radii do we have here? How many radius? 2. It's equal to 2r plus length of an arc, theta 1 over 360 degrees multiplied by 2 pi r. So this is the formula to find the perimeter of sector. This is the formula to find the perimeter of sector. This is the formula to find the perimeter of sector. Apart from that, you can be asked to find the area of sector. In case of the area of sector by formula is given as theta 1 over 360 degrees multiplied by pi r squared. So this is the formula to find the area of sector. And of course, we have all this formula in your fourth table. So the use of fourth table is allowed. Just take notes. Before I will introduce theorem in circle geometry, I just like to do this recap. Now let's go to theorem now. So let's go to theorems. The first theorem, theorem 1, under circle geometry. That theorem is the theorem that talks about a chord. Okay? The theorem says that if you have a chord, and this is the center of the circle, okay? The theorem says that a line drawn from the center of the circle to a chord bisects the chord. A line drawn from the center of the circle to a chord bisects the chord. That is, it divides the chord into 2 equal halves. Then if this is, and of course this is the radius, okay? This is another radius, okay? So the theorem says that if you have a line drawn from the center of the circle to a chord, that line bisects the chord into 2 equal halves, okay? That's what the theorem says. That here will be angle 90. Bisection simply means this is 90 degrees. Okay. So if you are given the radius and you are given one side, maybe you are given the length of a chord. Let's say you are given the length of a chord, then we can go ahead and find any problem. We can go ahead and solve any problem, any given problem under that. So I want us to check example. Let's check example on past question. Let's check example. Let's take example. So there's one example here. There's one example here on this theorem. We can get example on this theorem. Okay. Okay. So that's first theorem. The first theorem says that if you are given a circle, a line drawn from the center of the circle to a chord, divide the chord into 2 equal halves. So the line divides the chord into 2 equal halves. So let's just take note. Let's take note of that first theorem. That's theorem 1. That is theorem 1. Let's take note of that first theorem. That's theorem 1. That is theorem 1. So let's take example on that theorem. I'm with the past question here. Just looking for an example. Okay. Let's take an example. So there's one example here. Okay. Let's look at this example. This question now. This question I'm about to write is a YA question. Question is a theory part. 2004, question 12. This is what we have there. We have this diagram. We have this diagram there. So this is the diagram. Here is the center of the circle, 0. Here is Q. Here is P. And of course, we have this place to be Y. And there's another place. There's another chord here. There's another thing. So the question says in the diagram, 0 is the center of the circle of radius x. The radius is x. If this is x, yeah. If this is x, this will also be x. Okay. Of radius x. Let us write it that way. Of radius x. PQ is equal to z. That is PQ, the length of the chord. The length of the chord PQ is equal to z. That's the length of the chord. PQ is equal to z. And OK is equal to y. OK is equal to y. OK is y. That is OK is the distance from the center of a circle to the chord. That is OK is equal to y. And angle OKP is equal to 90 degrees. That is angle OKP is 90 degrees. That this face is perpendicular. You know, when you have something like this, it is not perpendicular. That's the way you have to straight. When the meeting point between the vertical and horizontal line, we normally say that it is perpendicular, and that perpendicular simply means this face is 90 degrees. Okay, that's what we have there. The question now says that we should find z in terms of x and y. So we have to find z in terms of x and y. So what do we do here? Just look at what do we do here. Just look at what do we do here. Look at the board. Okay, we are going to look at the theorem now. What does the theorem state? Let's look at the board. In this place now, we are given the distance from the center of the circle to this point to be y. We are given the radius as x, and we are given the length of the circle, the whole length of the circle as z. So we have to find z in terms of x and y. So what are we expected to do in this particular question? That is the question. So what do you think we can do in this question? Of course, we know the radius, we know the distance from the center of the circle to the chord. Then we know the length, we know the length of the chord. So what do we do? If PQ, the whole length is z, then we just say that PQ, the whole length of the z will be equal to QK plus KP, and everything is equal to z. Then we know from the theorem that the line from this center, the line from the center of the circle here, the line from the center of the circle, divide this into 2 equal halves. So if the whole length is z, then this place will be z all over 2, and here will also be z all over 2. Z all over 2. That's what we are going to get. So we say that KP will be equal to z all over 2. It will be z all over 2. Then if you not consider, let's consider let's consider triangle OKP. That is, let's consider this triangle, the one that we have here. What can you say about triangle? You know that triangle is a right angle triangle. That triangle is a right angle triangle. The triangle we have there is a right angle triangle. So what can you say about that triangle? That triangle is a right angle triangle. And if this is a right angle triangle, we are going to apply Pythagoras theorem. Pythagoras theorem says that, you know, this is the angle. This is 90 degrees. The longest side here is OP. So we say OP squared is equal to OK squared plus KP squared. Pythagoras theorem. We want to write Z in terms of X and Y. What is OP? OP, what is OP? OP is the radius, which is X. This is S squared. Is equal to, what is OK? OK is the distance from the center to the chord. That is Y squared, plus, then what is KP? KP is just the half of the chord. The chord is Z all over 2. Half will be Z all over 2. Chord is Z, then half of it is Z all squared. So from here now, what do? We are going to say this is Y squared to be equal to Z squared plus Z squared all over 4. We take the SCM. SCM here will be 4. From here, I'm going to have 4 Y squared plus Z squared to be equal to, then if you cross multiply, if I cross multiply, I will have 4Y squared plus Z squared to be equal to 4S squared. So we have to write Z in terms of X and Y. That's what we are going to get. That is what we are going to get. So that's what we are going to get. So from here now, from this point down, what do? I can transfer this to this other side, so that I will have, from here now, I will have Z squared to be equal to 4x squared minus 4y squared. Of course, we can have Z squared to be equal to 4 is common. Then I'll bring out 4, x squared minus y squared. Okay, this Z has squared, so I can take the square root of both sides. If I take the square root of both sides, I'm going to have Z square root cancel square root. I want Z equal to, what is square root of 4? That is 2 square root of x squared minus y squared. So this is what we are asked to do. We are asked to find Z in terms of X and Y. And if you can simplify further, you can say this is everything as 2 square root of, you know what you have inside is difference of 2 squared. It can be x minus y into brackets x plus y. So this is what we are asked to do. This is what we are asked to do. We have to find Z in terms of X and Y. And that is what we have. That's what we have done on the board. That's what we have done on the board. So that's what we have done on the board. Okay? So that's what we have done on the board. So that is the first theorem. The first theorem says that angle, a line drawn from the center of the circle to any part of the circumference is called, to any part of the circumference, divide a line drawn from the center of the circle to the chord, divide the chord into 3 halves. Then we go to theorem 2 now. Theorem 2. Theorem 2 says that angle at the center of a circle is twice the one at the circumference. Angle at the center of a circle is twice the one at the circumference. Let's see what I'm talking about. If this is the center of a circle, okay, let's say this is the center of a circle, O. Then any part of the circumference, we can say something like this. If this angle here is X, the angle at the center will be 2x. That's what the theorem says. Look at it. I'm going to tell us how we are going to get that. Say this is A, B. Theorem 2 says that angle at the center, this is the center of the circle, where we have O is the center of the circle. Angle at the center of the circle is twice the one at the circumference, provided they are subtended by the same arc. Look at the board. How do we know that this angle here is 2 times this angle here? Look at this angle here. It's from this point back to this point. It's from point A to point B. Look at this angle at the center. It's from point A to point B. Both angles are connected with the same chord, so they are suspended by the same arc. It is this arc that suspends the two angles. So if you are sure that it is the arc that suspends the same thing, then you can generalize and say angle at the center is twice the one at the circumference. Okay. Of course, you can also have something like this. You are the one that will do the tracing yourself. Let's say this is center, and you have something like this. if you have something like this, I can decide to write something like this, say something of this nature. It's still the same thing because this is the starting point here, this is the ending point. Okay, this angle here, if this angle is y, the angle here will be y. It will be 2y. Why? Because when you trace this, you realize that they are subtended by the same arc. This angle at center starts from A back to B. Angle at circumference starts from A back to B. So we can use that theorem too, which says that angle at the center is twice the one at the circumference. Okay, it's twice the one at the circumference. So in this case, that's what we are going to do. If this place is C, what we are going to say is that we say angle AOB. Angle AOB is the angle at the center. Is equal to 2 angle ACB. Okay, we say angle AOB is equal to 2 angle ACB. Angle at the center twice the one at the circumference. That's what we are going to get. Okay, that's the second theorem. That is the second theorem. So on this second theorem now, we can actually check. So let's get one or two examples on this second theorem. Let's get one or two examples of this second theorem before we move to another theorem. So let's get one or two examples on this second theorem. Okay. Let's get to a question on this second theorem. Theorem 2. We just want to apply this theorem. The theorem says that angle at the center is twice the one at the circumference. So let's get a question on this. Okay. So this question is question 1989, question 43, objective. This is what we have here. This is what we have here. This is what we have here. We have something of this nature. This is the center of the circle. And this angle is 114. 114. This is P. This is Q. This is R. This is what we are given. This is what we are given. We are asked to find angle PQR. Okay? So what do we do here? We are asked to find angle PQR. How do we find angle PQR? What do we do here? We are going to apply the second theorem. How do I know that we are going to apply the second theorem? Look at this diagram now. Look at the diagram. You know, this is the angle here. The angle here is 114. Okay? And we are looking for angle PQR. PQR. We are looking for this angle. This angle. Okay? So how do we solve this? Please, so there's one theorem that talks about cyclic quadrilateral. It's different from this. So, okay, when you talk about cyclic quadrilateral, this and this is not the same. Let's just say that when you have something like this, you realize that all the four sides of this quadrilateral touches the circumference. In this case, they are not the same. Here is only 3 points, 3 sides that touch the circumference. The last side is at the center. But in this case now, all the four sides, all the four vertices touches the circumference. So they are not the same. This one is different from this. So just note, this one is different from this. So if you have something like, if you have this type of question now, we are going to apply theorem 2, which says that angle at the center is twice one at the circumference. Look at this now. Look at what we have here. Look at what we have here. We are looking for this angle. How do I get this angle? Of course, this case is 114. Yes, 114. But I know that 114 plus the angle that I have here, the bigger one, plus this angle, let's say angle O, is equal to 360. How do I know? Angles at a point. Angle at a point is 360. Plain geometry. Angle on a straight line is 180. Okay? Sum of angle in a triangle is 180. Look at angle at this point 0. The point is 360. So the point 0 now, the angle will now be 360 minus 114. Then that's going to give us 246 degrees. So the angle here, this upper angle here, the angle here will be 246 degrees. Okay, the angle here, this upper angle is 246 degrees. If you have the two angles together, you must get 360 because that is the theorem. Angle at the point is 360. So, but that's not what we are looking for. We are looking for this angle Q. How do I now get angle Q? look at the angle at center. The angle at center here, it starts from here, from P back to R. The angle at the circumference here starts from P back to R. So we can apply that second theorem, which says that this is what we are going to say. We are going to say that angle POR, the one at the center here, this center is O, angle POR is equal to 2 times angle PQR. That's the theorem that we are going to apply here. Okay, what is angle POR? Angle POR is 246 degrees. It will be equal to 2 times angle PQR. Divide both sides by 2. Divide both sides by 2. This will cancel this. So angle PQR that we are required to find will now be 123 degrees. That's what we are going to get. Okay, so you have to trace it, provided they are subtended by the same arc. Angle at the center of a circle is twice the one at the circumference. So the right option in that question is 123. That will be 123. So the right option there will be 123. So that is the second theorem. Angle at the center is twice the one at the circumference. We now move to the third theorem. The third theorem states that angle on the same segments are equal. That's what the theorem says. The theorem says that angle on the same segment are equal. Look at, if this is a chord, how do we know that they are on the same segment? If I have something like this, look at it. Look at it. If I have something like this, let's say this is x1 and this is x2. Let's say this angle AB. Let me join this. This is PQ. Okay. How do I know if they are on the same segment? This is what will be given out. You can have the diagram in this form. You are the one that will do the tracing. Look at this angle P here, which is S1. It starts from here back to B. This angle Q here starts from here back to B. So if you trace it, you realize that they are suspended by the same arc here. Okay. Then if you trace this, if you put the chord, the upper one will be major segments, while the smaller one will be minor segments. So these two angles, S1 and S2, they are on the same segment. They are on the same major segments. So the theorem says that angle on the same segments are equal. Okay? Angle on the same segment are equal. You just say that angle APB is same thing as angle AQB. Reason, angles on the same segments. And you must note, if this is not subjective, multiple choice question, you don't need to put reason. But if this theory is compulsory, you cannot make any assertion in circle geometry without reason. If you say A is equal to 20 degrees, you must tell us the reason. So you have to state the reason. It is compulsory in mathematics, especially in geometry. When you make any assertion, you must tell us the reason why you say the reason why you say you make that statement. So if you have something like this, now this is the third theorem. Angle on the same segments are equal. How do you determine the segment? As I said earlier, just look at the starting point and the ending point, trace it, then join the two together. It's going to give you can join it with broken line as a chord. At the end of the day, you realize that a chord divides the circle into two. The bigger segment is called the major segment, and the smaller one is called the minor segment. So you realize that all these two angles, they are on the same segment. So angle on the same segment are equal. So angle on the same segment are equal. And that is the theorem that we are going to use to prove, we are going to apply to solve any problem of that nature. So let's see question on that nature. Let's see question. Let's take past question that you can actually use that theorem to solve. Look at me, I'm not look at the question. I know what to do. Nobody will tell you what to do. You just look at the question, then you go ahead and solve. You are the one that will just look at the question, then you solve it. That is what is required. So let's look at this question now. Okay, maybe we solve two questions on this. We solve two questions on this. The question says that in the diagram below, this is diagram. In the diagram below, this is diagram. We have this something of this nature. So this is P, this is Q, this is S, and this is R. So the question says that in the diagram below, angle SPR, that is this angle, Angle SPR is equal to P, small letter P. Then angle SQR is equal to 2x. Here is 2x. Okay. The question now says that we should find x in terms of P. Okay. Look at this now. What do we do here? Is this objective question? So how do we pick the right option? Look at the diagram very well. Look at this diagram. As I've said earlier on, what we are going to check, if you want to, if the second theorem, which says angle at the center is twice one side circumference. What do you check? You check where the angle starts from and where the angle ends. This theorem 3 also, angle on the same segments are equal. You check the starting point and the ending point. Look at this angle P. It starts from here back to R. Angle Q also starts from S back to R. Okay. So if you use profile to trace this one out now, you realize that angle P and angle 2x, PQ, angle PQ, they are on the same segments, major segments. So we can say that P is equal to 2x. But this is objective question. The right option will be this. Just go ahead and pick the right option. P is equal to 2x. But if this is theory, you are asked to prove. Then what do you tell us here? Why is P equal to x? That is, what we're trying to say is that angle SPR is same thing as angle SQR. That's what we are trying to say. Then what is the reason? Angles on the same segment. That's the reason. That's the reason. Then what is angle SPR? That is P, small letter P. It's equal to angle SQ, that is 2x. So this is the right option that you take there. This is the right option that you are going to pick there. So that's what you do. So that will be the right option that you're going to pick. So that is that about the third theorem. And the fourth theorem, that one is very simple. That one just says that angle in a semicircle, is right angle, is 90 degrees. That is, in that case, you must have a diameter in the circle center O. Then this angle, if you have something like this, say A, B, then C. That theorem says that this angle C here is 90 degrees. Okay, it's just the same assertion that is angle at the center is twice one as circumference. You know, in this case now, the center is the diameter. So angle on the straight line here at the center is 180. Angle at the point is 360. So in a point, if you have a point and a line drawn through the point, that line will divide the point into two. Okay, so the fourth theorem says that angle in a semicircle is right angle, that is 90 degrees. So that's just the theorem. So if you have any question on this, it's very simple and straightforward. Just look at that, then you just write your answer. You just go ahead and write your answer. So we can pick one question there. So we can pick question there. We'll just move. Okay, let's take one question on this fourth theorem. Let's take one question on this. The fourth theorem says that, how do you know this fourth theorem? Angle in a semicircle. Angle in a semicircle is right angle, is 90 degrees. That is, we are saying that angle ACB is equal to 90 degrees. Right angle similar, this angle similar. Then how do you do that? This must be a diameter. AB must be diameter. It's different from chords that we have been looking at from previous theorems. So in this fourth theorem now, let me just give one example. Let's give one example. Look at this now. This past question, where we have something of this nature. I'm going to write it. I'll write everything. So the question says that in the diagram, O is the center. O is the center. So once O is the center, it shows that this line QR is the diameter. Then here is X. The question says that O is the center. If angle QRS is 62 degrees, if this place is 62 degrees, we have to find the value of angle SQR. Find the value of angle SQR. We are looking for this value. Again. So how do we get that value? Without wasting time, we can actually get that value because this is the diameter. It shows that this angle here is 90 degrees. That's what the theorem says. That angle in a semicircle is 90 degrees. So if you are sure that this is the diameter, then we have the triangle here, something of this nature. This angle is 90 degrees. Then we are looking for this case. So angle SQR plus 90 degrees plus 62 degrees is equal to 180. How do I know that? This is a triangle. Sum of angle in triangle. You know 2 out of 3 unknown. You can find the last one. So that angle SQR will now be equal to plus 152. Here will be 152. It's equal to 180 degrees. So angle SQR will now be equal to 180 degrees minus 152. So that will be 28 degrees. So once you look at this question now, you should know that we are going to apply theorem 4. Angle in a semicircle is right angle. Then I'll go to theorem 5. Theorem 5 is where you have a cyclic quadrilateral. Theorem 5 is where you have a cyclic quadrilateral. That is, you have a quadrilateral inscribed in a circle. Something like this. Please, I want you to get something right. Let's get something right. In this case now, this is a cyclic quadrilateral. Why is it a cyclic quadrilateral? Because it's a quadrilateral. Quadrilateral is four-sided shape, right? So this quadrilateral is inscribed in a circle. So it's called cyclic quadrilateral. So it's different from something like this. It's different from this. It's not the same thing. If this is a center, say, oh, you now have something like this. They are not the same. In this case now, this one is the center. We only have three. Three of this quadrilateral here touches the circumference of the circle. The last one does not touch the circumference of the circle. So this one is not cyclic quadrilateral. Please, let's get the difference. In this case now, you either apply from theorem 2 to theorem 4 to solve the problem of this right hand side, A of this B. But this A is a cyclic quadrilateral because all the four vertices of that quadrilateral touches the circumference. So this is a cyclic quadrilateral. This is not. So please, let's get the difference. Okay, let's get the difference. So theorem 5 says that the opposite angle of a cyclic quadrilateral are supplementary. That is, if this is angle X and this is angle Y, the theorem says that angle X plus Y is equal to 180 degrees. You know, when you have complementary angles added up to be 90 are complementary. But when you have supplementary angles are angles that are added up to be 180. So that's what the theorem 5 states. Theorem 5 states that the opposite angle of a cyclic quadrilateral are supplementary. That is X plus Y. In this case, S plus Y is not 180. This one is also opposite, B and D. So if this is M and this is N, we can say that M plus N is equal to 180. Okay? The upper angle of a cyclic quadrilateral are supplementary. That's what the theorem says. Then I want to combine two theorems now. This theorem 5. Opposite angle of a cyclic quadrilateral are supplementary. And there's another theorem. Which is extension of this theorem. The theorem, look at it. The theorem says that if you have a cyclic quadrilateral, as we have it on the board, okay, and one side of the quadrilateral is produced, that is, if we extend one side of that quadrilateral, okay, if you have a cyclic quadrilateral and one side of that cyclic quadrilateral is produced, we extend it. The exterior angle of this quadrilateral here, let's say it is Y, is equal to the interior opposite angle. That's what theorem 6 states. That if you have a cyclic quadrilateral and one side of that cyclic quadrilateral is produced, we extend one side of the quadrilateral. The exterior angle formed here is equal to the interior opposite angle. That is here, S is equal to Y. Just say exterior angle of a cyclic quadrilateral. Okay, that is theorem 6. So let's just take example on this theorem. Let's take example on theorem 5 and theorem 6. So once we take example on theorem 5 and theorem 6, then we can go to another topic. So we still have about three other theorems. So though they are not, they are important. When we talk about tangents, when we talk about alternate segments, but because of our time, we skip that. We just go ahead and find what we have here. Okay, this is another question. Look at this question now. This is a question on cyclic quadrilateral. Let's know the difference. So In case of circle quadrilateral, all the four vertices must have a touch with the circle. So it's different from the previous problem that we solved. Here is 79 degrees. So this place is P, Q, R, X. Now let's listen to the question. The question states that in the diagram below, angle SPQ is 79 degrees. Find angle SRQ. We have to find this angle. Of course, this is a multiple choice question. This is a question 36, 996. So in this type of problem, you don't have any problem. You don't need to stress yourself. If you are sure that this is a side quadrilateral, all the four vertices touches the circumference of the circle, what we just do is that just add these two angles together and say it's 180. That is, just say angle 79, that's 79 degree. That is angle SPR plus angle SRQ that you are looking for. It's called to 180 degrees. But because this is an objective question, you don't need to write it. But if this is theory, you must tell us the reason of opposites. You tell us the reason, opposite angles of a cyclic quadrilateral. You have to tell us the reason. Then angle SRQ that we are looking for just be 180 minus 79 degrees. So that will be 101 degrees. That's the answer. Okay, that's the answer. So without stress, you can, if you have this type of problem, objective multiple choice question, just go ahead and pick your answer. It's very simple and straightforward. These are very simple and straightforward questions, provided you know the theorem that guides some of this circle geometry. Once you know the theorem, you don't need to stress yourself. Just go ahead, apply the theorem, and pick the right option. That is what you are asked. You will be required to do. So that's that about that. Then there's another one here. There's another one here where we are asked to find. Let's treat it one or two questions under the theory part. The theory part. Okay. Okay. So let's treat this question. The one I'm about to write on the board now. This is why question. Is why question. So this is circle geometry. We are still under circle geometry. Maybe this will be the last example so that we can go to another topic. We have a lot of topics to consider. So let's look at this question. Let's look at this question. It's very simple. Just that. So we have A, B, C, D. Then here is E, and here is F. So let's take what we are given. Let's just put what we are given. In the diagram above, A, B, C, D is a circle. Is a circle. Then DAE, CBE, ABF, and DCF are straight lines. If the question says if y plus m is equal to 90 degrees, find the value of x. Okay, so this place is called x, and here is y. That's what we are given in the question. So let's look at the question very well. The question is simple, though it appears as if it's complicated, but it's a very simple question. Once we know the theorem that we are going to apply, so it's very simple. So what do we do here? We just recall our knowledge from both plane and circle geometry. Let's note that we are given y plus m to be equal to 90 degrees. Y plus m to be equal to 90 degrees. Okay. So then there is A place should be there should be M somewhere. We should have M somewhere. Let me check the question very well. There should be M somewhere. So we want to find X. We want to find X. There should be M somewhere. BAD. The angle BAD. BAD. Angle BAD. Angle BAD. There's typographical error here. There should be M somewhere in the question. We should have M somewhere. If Y plus M, Y, where's Y? Is equal to 90 degrees. We should have M somewhere in the question. We should have M. Probably M. We should have M somewhere in the question. And PAT. And PAT is equal to X plus M. Something is wrong here. There's an omission here. We should have M somewhere. We should have M somewhere. Let me check the question from another perspective. There should be M somewhere. Because since we have that assertion, since we have that statement, since we have the statement where we have Y plus M is equal to 90 degrees. So I think something is wrong with the question. There should be M somewhere. Let me check another past question. But it's an incomplete, that's an incomplete statement. There should be M somewhere. There should be M somewhere. Let me check another past question. We must have the value of M somewhere. I don't know where I kept this past question. I'm 100% sure that there should be M somewhere. Yes, that's what I'm trying to look at. In this question now, the question is not that clear. The M was not indicated. And we have if Y plus M is 90 degrees, find the value of it. So there should be M somewhere. There should be M somewhere along the line. We must have M. Without that M, we can't do anything. There's nothing we can do here. If you don't know where M is placed, then it will be difficult to be able to solve the question. AB, I'm coming. ABX is X. ABE, 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 ABE is X. Yes, that's okay. Then BAD is X plus M. BAD is angle. The angle here is same thing. The angle here BAD is what's BAD? The angle here can be equal to the angle here. Okay. The extension here can be equal to what we have here. So there should be M somewhere. Okay, probably if you say this place is M. Assume that place is M. assumption. Can we get something out of there? And if you have your past question, it's not clear there. You can help me to check. If you have your past question, you can help me to check the theory question. Theory 1998 question 5. Please, if you have your past question, please help me to check. 1998 question 5. Go ahead. This compilation is just photocopy. Please, if you have your past question, help me to confirm where we have M there. 1998 question 5. 1998 question 5. So please, if you are with compilation, that's past question and answer, mathematics. Help me to check 1998 question 5. Help me to check 1998 question 5. I want to know where that M is situated. So please, I'm expecting your response. I'm expecting your response, please. If we cannot get that, then probably I will pick another question, because I don't want to assume anything. We must pick a question that we are sure of. So I don't want to assume anything. We must be sure of what we are doing. So we can't base our teaching on assumption. Okay, if you cannot locate the value of M, then probably I will pick another question. Let me pick another question. Not to waste our time, I'll move to another topic. Let me pick another question. Question that involves cyclic quadrilateral. You can even get this. You can get it online. So were you able to get it? No response. Okay. Let me pick another question, because I don't want to assume. I don't want to make assumption, because if we assume that this space is M, then we might have problem if we are not sure of where the value of M is. So an assumption is not allowed. It's risky, because I'm not going to confuse you guys. Okay, so it is not clear in this last question where we have M. M was not stated. We don't have M here. Okay, so we can pick another question. I will pick another question. Let me give another question. Let me pick another question. What I'm sure of. Let's pick another question that I'm sure of the position. Let's pick another question. Thereafter, we'll now move to the next topic. So let's pick another question. They're not the same, but they have something similar. It's something similar. Okay, let's pick another question. Look at this question. Look at this question. Look at this question. We have something of this nature. It's also a question. This is also a question. This is a question where we have this space to be 60 degrees. 60 degrees. Here is x degrees. Here is x. This space is E. Here is A, B, C, D. Okay, and this space is 2x degrees. So the question says that in the figure below, calculate the value of x. Calculate the value of x, giving a reason for each step in your answer. We have to calculate the value of x, giving a reason for each step in your answer. So we want to calculate the value of x. the theorem 6 says that if one side of a cycle of tetra is extended, if you extend it, is produced, the exterior angle formed here is equal to the interior opposite angle. So in this case now, I can say angle B. In this case now, I can say that angle BCE. I can say that angle BCE is equal to 2x naught. That is exterior angles of a cyclic quadrilateral. So I can say this angle here, angle BCE here. This angle here is same thing as this angle here, based on theorem 6. Okay. Then angle, if you consider triangle BCE, if I add all the angles together, I must get 180. I will have 60 degrees plus 2x degrees plus x degrees is equal to 180. That will be sum of angles in a triangle. In a triangle. Then if that is sum of angle in the triangle, then I will have 60. I will have 3x to be equal to 180 minus 60. So 3x degrees x will now be equal to 120 degrees. If I divide both sides by 3, my x will be equal to 40 degrees. So that's what you get. That is what we are going to get there. So you have to be sure of the question that we pick so that we don't have any problem. So then I can move to another topic. I can go ahead and I can move to another topic. So let's move to can I introduce bearing, or can I introduce bearing? Or I should start with sequence and series and sequence, AP and GP. Please comment. Let's know. Can I introduce bearing, or I should start with AP and GP? Bearing and distance. Can I introduce bearing, or I should start with AP and GP? So please comment. Let me know. Please comment. I'm expecting your comments. So let's move to another topic. Let's move to another topic. So I cannot see any comment. So let me quickly revise sequence and series. So I'll quickly revise sequence and series. So that's what we call AP and GP. Thereafter, I will move to bearing. That's what we call AP and GP. Arithmetic progression and geometric progression. Okay. So what's the sequence? A sequence is the number that is arranged in a sequential order. A sequence, for instance, if you can have 1, 3, 5, 7, dot, dot, dot. So this is a sequence. Why is it a sequence? Because it has a common difference. The difference between 1 and 3 is 2. This between this and this is 2. This is 2. So this is a sequence. It's a sequence because it has a common difference. Okay? It's a sequence because it has a common difference. It has a common difference. So it's a sequence because it has a common difference. Okay? So the first term of a sequence is denoted as T1, is denoted as A. The first term of this sequence is T1. The general notation is A. The second term of a sequence is when you add the first term plus the common difference. The common difference is denoted as D. So how do I get the first term? The first term is always given A. The common difference is first term plus the common difference, which is D. So in this particular question, the first term is 1. The common difference is 2. So that will be 2. Then we are able to get 3 as the second term. The third term is Between the first and third term, there are two common differences. There are two d. So we are going to have a plus 2d, which is equal to 1 plus 2 into bracket 2. Then we have 1 plus 4 is equal to 5. So if we continue in this order, then the last term, which is called the n term, will be given as a plus, look at, when you have 3 here, the third term, the coefficient of d here is 2. When you have 2 here, the second term, the coefficient of d here is 1. So where you don't have n here, the coefficient of d will be n minus 1 d. So this is the formula to find the last term or the nth term of an arithmetic progression, AP. The last term of an arithmetic progression, AP, is called this formula to find the nth term or last term of an arithmetic progression. Okay, this is the formula to find the last term of an arithmetic progression, last term of an arithmetic progression. So arithmetic progression, we talk about progression when we're talking about sequence. Sequence is just number arranged in orderly manner. So arithmetic progression, this is the formula to find the last term or nth term of an arithmetic progression. Arithmetic progression is otherwise known as linear sequence. It's what is called linear sequence. It's called linear sequence, okay? It's called linear sequence. So this is the formula to find the arithmetic progression, the first term, the last term of an arithmetic progression. That's about that. Under linear sequence, we talk about common difference. Common difference is D that you have. When we are dealing with AP, we talk about D. But when we are dealing with GP, geometric progression, we talk about R, common ratio. So if you want to know the next term of an arithmetic progression, you keep adding the common difference. So this is the first term. If I want to know the next term, I'll just say 7 plus 2. That will be 9. If I want to know the next one, that will be 11, and in that order. Then if I want to know the common difference, I will subtract the second term from the first term, or third from the second, and in that order. Common difference is second minus first. Okay. Under arithmetic progression, we talk about addition and subtraction. Okay, because it's a linear sequence. It's a linear sequence. So this is the formula to find the nth term or last term of an arithmetic progression. Then that's the formula. Then what if we now have geometric progression, where we have something like 1, 2, 4, 8, dot, dot, dot. In this case now, the difference between the first and the second is 1. The difference between the second and the third is 2. The difference between the third and the fourth is 4. This one is no longer linear. It's not the same. It's not the common difference, but we have something in the form of a ratio. 1, 2, 4. It's the form of a ratio. So what do we do here? The first term, T1, of course, is the same thing as A. We also call it A. But how do I get the second term? In this case, I'm going to say the first term multiplied by the common ratio. What is the common ratio? That is R, in this case, will be second term divided by first term, or third term divided by second term. That's, we have common ratio. This is geometric progression, or otherwise known as exponential sequence. But the first example I gave is R, that's where we have G. It will be second term minus first term, or third term minus second term. The first example is AP, linear sequence, arithmetic progression. This second example is GP, is geometric progression. So under geometric progression, we talk about common ratio. We talk about common ratio. Okay, we talk about common ratio. So we have to understand that. We talk about common ratio. So the first term is A, the second term will be A times R. So A is 1 times 2. We get 2. Then the next one, C3, will be AR squared. There will be 2 common ratio that we're going to have there. So there will be 2 common ratio there. So in this case now, A is 1, then the common ratio, we are getting the value of the common ratio. The common ratio here will be 2 divided by 1, which is 2. The common ratio is 2. So we have 1 times 2 squared. That will be 4. The fourth term will be AR3. That is when the subscript is 3 here, the power is 2. When the subscript is 4, the power is 3. So we have 1 times 2 raised to power 3, which is equal to 8. So if we continue in that order, the last term or the nth term will now be ARN minus 1. This is the formula to find the last term or n term of a geometric progression. Okay. Okay, maybe after this I should go to graph. After GP, I'll go to graph. So we take about 4 types of graph. We start with quadratic graph, street graph, trigonometric graph, inequalities. So don't worry. Then we talk about no give. After this, I'll go to graph. After this, I'll go to graph because graph is compulsory. Graph is compulsory. At least you have one question on graph. So I may not know. It might be trigonometric graph. It can be quadratic graph. So after this, I'll go to graph. After this, I'll go to graph. Or if you don't have any problem under sequence and series, I can skip this and go to graph. Do I need to continue this? Do you understand sequence and series, AP and GP? So if you understand this, I don't need to waste time. I'll just go to graph. Please, I need your comments. Do I need to continue? Do I need to talk on this? Okay. So this is the formula to find the last term or n term of a geometric progression, and that is what we have on the board. Okay. Under geometric progression, we have common ratio. Under GP, we have common ratio. Under AP, we have common difference D. So this formula to find the last term. So that is sequence. Then what do we call series? Series is addition of all the terms that we have in the sequence. For instance, like the example I gave, 1, 3, 5, 7, 9, dot, dot, dot. This is a sequence. Then when we talk about series simply means when we now had when we had everything in the sequence together, it's called series. Series is addition of all the terms. Series is addition of all the terms that we have in the sequence. That's a series. Then for series, I'll just go ahead and write the formula. For an arithmetic progression, if you have AP, the formula to find the series, the sum of an AP is n all over 2 into bracket 2a plus n minus 1 into bracket d. This is the formula. But if you are sure, if you are given the first and the last term, it can be the same thing as n all over 2 into bracket a plus l. That is, you know the formula, if I can split this a plus a, 2a is a plus a, then a plus n minus 1 into bracket d. What we have here is the formula to find the last term of an AP or n term of an AP. So if I split it, I will only have 1a, then L, where L is the same thing as a plus n minus 1 into bracket d. This is the formula to find the last term or the next term, n term of an arithmetic progression. So this is the formula to find the sum of AP. Sum of AP, this is the formula on the board. Is that you use this first one. All this formula, you don't need to memorize it. You have it at the back of your 4-figure table. So it's at the back of your 4-figure table. So and the use of 4-figure table is allowed. So you are covered. So this is the formula to find the sum of AP. But when it comes to GP, sum of GP, there are 3 formulas involved depending on the value of R. If the value of R is greater than 1, then the sum of GP has its own formula. Okay? If R is greater than 1, GP has its own formula. If R is less than 1, there's another formula. If R tends to infinity, we also have another formula. So please let's note, for AP is only one formula that we use to find the sum of AP. Sum of arithmetic progression is only one formula. But when it comes to GP, there are 3. We have 3 formulas that we apply when it comes to GP, geometric progression. Depending on what, so when R is greater than 1, the formula will be, when R is greater than 1, the formula will be A into bracket R raised by n minus 1 all over R minus 1. When R is greater than 1, we apply this formula. When R is less than 1, it is the value of R that will determine the formula that we apply under sum of GP. Let's note, the sum of GP will be A into bracket 1 minus R raised by n all over 1 minus R. When R is greater than 1, we apply this formula to find the sum of GP. When R is less than 1, of course, when we have 0 point something fractional, we apply this second formula. Then when R, so when we have sum to infinity, that is if we have sum to infinity, we are going to have the formula to be a all over 1 minus r. Most of the time in objective question, we'll be asked to find the sum to infinity. Then we are asked to find sum to infinity. This is what we are expected to do. So we can go to example now. We can go to examples. Let's take example, maybe 3 or 4 examples, then we go to graph. After the example, we now go to graph. We go to graph, then maybe after graph, we come back to bearing. We are going to go, we come back to bearing. Bearing and distance. Because bearing and distance is also another important topic. Bearing and distance. Then if there is time, we go to elevation and depression. Then we can also talk about latitude and longitude. Okay? Alright, let's take an example. In this case now, this is 2015 question 5, where we have find the seventh term of this sequence. This is sequence 2, 5, 10, 17, dot, dot, dot. The question now says that we should find the seventh term. Seventh term. Of course, A, the first time is denoted as A, as we have said it, as we have. No, is that what we have? Okay. Okay. Now look, let's look at this. What do we have here? What do we have on the board? Find the seventh term of the sequence. 17. Here is 26. There is 26 here. Dot, dot. Okay. What is the nature of this sequence? What's the nature of this sequence? Do we have common difference here or ratio? What's the nature of this sequence? Please, let's look at it very well. What is the nature of this sequence? This is not a linear sequence, because between 2 and 5 is 3. Between 5 and 10, between 5 and 10 is 5. Between 10, look at here is look at the progression. This is 3. This is 5. This is 7. This is 9. Then the next one, this is 1st, 2nd, 3rd, 4th, 5th. The next one will be 11. The next progression will be 11. So that will be 37. The next one will be 13. So that will be 50. 1, 2, 3, 4, 5, 6, 7. The seventh term of this sequence will be 50. So without using formula, that is the answer. So please, you look at the nature of the sequence before you know what to do. You look at the nature of the sequence. So you look at the nature of the sequence before you know either it's linear or exponential, or like in this case now, it's not linear and it's not exponential. The sequence just have a particular format. The difference between this and this is 3. Here is 5. It is not common. The difference is not common. So we can't talk about common ratio or common difference here. The difference is not common, but it has a progression. You keep adding 2 to the next term, and to the difference of the next term. So the seventh term, this 7, here will be 50. That's what we are going to get. That's what we are going to get there. So the difference here is somehow unique. It's not common. So there's another question here. There's another question here. This is a theory question. It says that we should find the first term of an arithmetic progression. The first term of an arithmetic progression is 3, and the common difference is 4. Okay. This question is This question is 2002, question 7. The question says that the first term of an arithmetic progression, first term is denoted as A, T1 is denoted as A. So the first term of an arithmetic progression is 3. Okay, you write down what you are given is 3, and the common difference D is 4. The common difference is 4. This is 2002, question 7, theory is 4. The question now says that if you find the sum of the first 28, we should find S28 when n is equal to 28. Well, that's what we want to find. What is formula to find the sum of an AP? This is an AP. Once we use common difference is an AP. Common ratio, GP. The sum by formula is n over 2 into brackets 2a plus n minus 1 d. Okay? So in this case now, we want to find the sum of when n is equal to 28. We have to find the sum of the first 28 terms. So n is equal to 28, we have 28 all over 2 into bracket 2. What is a? Multiplied by 3 plus 28 minus 1, that's 27. Multiplied by d is 4. That's what we're going to get. Here I'm going to get 14 into bracket 2 times 3, that's 6 plus 4 times 7, 28. That's 108. That's what I'm going to get. So here I'm going to have 14 into bracket 114. So let's multiply that. 114 multiplied by 14. 4 times 4, 16. 5, 4. Here I'm going to get 411. That will be 6951. So the sum of the first 28 will be 1596. That's what you are going to get in that GP and in that AP. And of course, it's a progression. It's a progression. If you are asked to list the GP, you know the AP, you know what to do. Just say the first time is 3. 3. This is the GP, this is the AP. The first time is 3. Common difference is 4. So the next one will be 7. The next one will be 11. The next one will be 15, 19, dot. If you list all this up to 28 term and you add everything together, this is what you are going to get. That's what the question says. That's what you are going to get. That's what you are going to get. Okay? So that's that about sum of AP. We pick another question. Let's pick another question under GP. Let's pick another question under GP. Under GP. We pick another question under GP. Okay? So this is 2007. 2007 question 12. 2007 question 12. 2007 question 12. Let's look at this together. Where we have the third and the eighth. Where we have the third and the eighth terms. Oh, this is also AP. I'm looking for question on GP. I want to get question on GP. Okay. I've gotten one question. This question is 2006 question 39. 2006 question 39. Where we have find the nth term of the sequence 5, 10, 20, 40, 80, dot. Okay, this is a GP. Why is it GP? The common difference, the first term is 5. We know that. But you realize that there's progression. This is 5, 10. It's like they are multiplying by 2. So under GP, if you want to know the next term, you multiply by the common ratio. If you want to know the common ratio, you divide the second by the first. So the common ratio here will be divided by first. 10 divided by 5, that is 2. If I want to know the next term, I'll keep multiplying. Don't stop at 180. If I want to know the next term, it's 160, 320, dot, like that. So the question says that we should find the nth term or the last term of this GP. So by formula, the last term or the nth term of arithmetic progression is given as ARN raised to minus 1. N, but we know A. So what is A? A is 5. Multiplied by what is R? R is multiplied by 2 raised by n minus 1. Then what do we get here? What are we going to get here? At the end of the day, our answer will be 5 multiplied by 2 raised by n minus 1. That will be the answer. Because we don't know n. N is unknown. It's n term. So since we don't know n, then there's nothing we can do. We only stop at that point. Okay? We'll stop at that point. There's nothing we can do about that. So we have to stop at that point. We stop at that point. So we stop at that point. Then I want to introduce graph now. I want to introduce graph now. So let me introduce graph. I want to introduce graph now. So we are going to start with quadratic graph. We are going to start with quadratic graph. So let me introduce graph. I want to believe that we are familiar with linear graph right from junior secondary. We are familiar with linear graph, right? We are familiar with linear graph. We are familiar with linear graph. So I can just do a recap. I'll do something like revision. Let's talk about graphs now. So when we talk about linear graph, when we have y is equal to 2x plus 1, this is a linear graph. In a graph, there are two coordinates at your level. There are two coordinates. This is y axis and this is positive x axis. So we can also have negative x axis, then we can have negative y axis in a graph. So the center of the graph is called the origin. The center of the graph is called the origin, 0. The center of the graph is called the origin, and that is 0. So this is positive y, positive x, negative y, negative x. So if you have a linear graph, this is a linear graph. Linear graph simply means the highest degree of x here is 1, is linear. So what do we do? For us to be able to do anything on this graph, we must have values for x, because x is dependent, then x is independent variable. So you can be asked to plot this graph as x ranges from -2 to 2. These are the value of x. So if I want to plot this graph now, I must get a table. You cannot plot the graph without table. Okay, I will generate a table with the values of s from -2 to 2. So I will have -2, -1, 0, 1, 2. So what do I have here? I have 2s. I have +1. Then what is my y? This is y. What is y? Y is equal to 2s plus 1. Okay, I'm just doing the revision on linear graph. So how do I get y at each of these points? When we notice 2s, s is -2 here, -2 times 2, I'm going to get -4 here, -1, -1 times 2, -2 here, here is 0, here is 2, here is 4, and this is a constant. I'll just repeat it, +1, +1, +1, +1, +1. Then what is the value of y? Y is 2x plus 1. So I will add everything that I have here together. -4 plus 1, that's -3. -1, 1, 3, 5. So these are the value of x. The value of x here. I've been able to generate the value of y there. So I've been able to generate the value of y there. So what do I do if I want to plot that graph? I will now say, I will look at the range. S is from -2 to 2. I will put the value there. -1, -2. Here will be 1, here will be 2. So if you want to plot the graph, the first thing is that you must have a scale. If you are given the scale, it's fine. If you're not given the scale, you are the one that will generate the scale yourself, depending on the nature of the table. So in this case, you can say 2 centimeter represent 1 unit. That is, you are going to count 10 holes. The points, the holes that you have in that graph, 10 of it is 2 centimeter. So 2 centimeter represent 1 unit along the x-axis, or you can say you must have the scale on your graph. Your graph must have scale on both axes. You can say 2 centimeter represents 1 unit on both axes. Or you can use different scale. You can use different scale on x, you can use different scale on y. It is the scale that will help you. Whatever you use is what they're going to use to interpret your results. Then look at y. In case of y, it starts from -3 to 5. Then since this one starts from -3, it shows that you have enough points along the positive more than the negative. So we can go ahead and extend the negative, the positive. We extend the positive more than the negative because we have enough value at the positive more than the negative. So here we can have -1, -2, minus 3. Here I'm going to have 1, 2, 3, 4, 5. I'm not using graph here. I just want to sketch. Now, this is what you do. When x is minus 2, what is y? Minus 3. You come to when x is equal to minus 2, you trace it to where y is equal to minus 3. You put the point here. When x is minus 1, what is y? Minus 1. X minus 1, y minus 1 is this point. When x is 0, y is 1. When x is 0, y is 1. So when x is 1, y is 3. When x is 1, y is 3. Okay. Then when x is 2, y is 5. When x is 2, y is 5. You realize that when you plot this graph, of course, we are going to use ruler to join all this. So you are able to get a straight line graph. Why is it a straight line? Because what we sketch is a linear graph. So a linear graph is always a straight line. So let's note that when you plot a linear graph, it's always a straight line. It's always a straight line. So just this is graph of y is equal to 2x plus 1. Graph of y is equal to 2x plus 1. That's the graph. Then from the graph, you can use the graph to solve all the given questions that will be required here. They can ask you to find the value of y when s is equal to 3, or when s is equal to 1.5, is equal to 1.5. That is, this is 1.5. Just place it to y and tell us the value of y there. So from the graph, you use the graph to solve problem. So yesterday when I introduced quadratic equation, I said we can solve quadratic equation using graph. But if you want to solve quadratic equation using graph, you must have a graph book. Okay, so a linear graph is a straight line. So let me now introduce quadratic graph. Quadratic graph is parabola, is curve-like. It's curve-like because the degree of s there is 2. So let's introduce quadratic graph now. But at times you can have both graph, both linear and quadratic in a particular question. So we are going to pick one. We are going to do just 2 questions under this. Then we go to trigonometric graph. Trig also have graph. We have graph under trig. Trig has its own graph. Trigonometric graph. So let's look for a current, the one that is still current. Okay, this 2000. No, I'm looking for a very current question. Okay, 2018. Okay, there's a question here. We have a particular question here. This is 2023, question 8. This question is 2023, question 8. The question I'm about to write is 2023, question 8. The question says that copy and complete the table of values for y. For y is equal to 2x squared minus x minus 4. 4, this is the range. 4 minus 3 less than or equal to x less than or equal to 3. That's the range. In the graph, you must have a range. Let's note. So this is 2023 question 8, the theory part. So this is the table. Let me just sketch the table here. Most of the time, when you have question on the graph, you will be given a complete table. You'll be required to complete that table. So please, let's note. This is x, this is y. We have minus 3, minus 2, minus 1, 0, 1, 2, 3. This is the table. So we have 17 here and minus 4 here. So the question says that copy and complete the table of values for y is equal to 2x squared minus x minus 4. For this is the range. In every graph, there must be range of values from minus 3 to 3. Okay? That is the A part of the question. That's how they said question on that graph. Then the B part of the question. The B part of the question now. The B part of the question now says that Using a scale of 2 centimeter to 1 unit on x-axis and 2 centimeter to 2 units on y-axis, draw the graph. Before you can draw the graph, we must complete this table. Once we complete this table, then we go ahead and draw the graph. Then after that, we are not going to use the C part of the question now says use the graph to find the root of the equation. That is when y is equal to 0, that's the root of the equation. Then the value of s for which y increases as s increases. Then the minimum point of y. Okay, that is what we are asked to do, and that's what I'm about to start now. So now let's look at that is question 2023, question 8, theory question, and that will be 12 marks. This question will be 12 marks. It's 12 marks. The question is 12 marks. So once we are able to solve this type of question, we are going to get your 12 marks. We are going to get your 12 marks. It's as cheap as that. Okay, so let's go ahead and solve this question. I hope we are together. Let's go ahead and solve this question. Let's go ahead and solve that question. That question is, let's go ahead and solve the question. The question is 2023, question 8. 2023, question 8. That's what we are given. And that's what we are required to solve. So we go ahead and solve the question. Let's go ahead and solve the question. So what do we do? The first thing is to complete the table. You copy the table, then you complete. We're going to copy the table, then we complete the table. Let me do it here. This is x. What are the values of x? I will list, then I will complete. This is x. We have the value for x. Okay. What are the values for x? S is equal to from -3, -2, -1, 0, 1, 2, 2, then 3. 3. That's what you have. Okay. These are the values of x. Okay. Then what are we given? If you want to do that, we have to be very careful. What are we given? What are we given? We are given 2x squared. That's the first thing. We are given -x. You create another point for that. Then we are given -4. -4 is the constant. Then with that, we'll be able to find y. We'll be able to find y. So we first, this is how to generate the table. If you want to generate the table, you must find everything out. You spell it out like this before you be able to generate the table. So your inability to do this is going to give us a lot of problems. So this is how to generate the table. So in this case now, x, we have 2x squared. S here is -3. -3 times -3, that's 9. 9 times 2, 18. S here is -2. -2 times -2 is 4. 4 times 2, 8. Here is 2. Here is 0. This is 2. This is 8. And this is 18. Okay? We have -x here. Minus times -3, this will be 3. This will be 2. This will be 1. This will be 0. Here will be -1, -2, -3. And the last one is the constant, -4, -4. Just repeat it for all the column. So what is y? Y is addition. You add everything together here in order to get y. Add everything that from here to here. You add everything together to get y. 18 plus 3 is 21. 21 minus 4, that's 17. That's where they got their 17 from. 8 plus 2, that is 10. 10 minus 4, 6. 2 plus 1, 3. 3 minus 4, -1. Then this is -4. 2 minus 5, -3. Here we have 8. 8 minus 6. 8 minus 6, that is 2. Then we have 18 minus 7, that is 11. This is what we are going to get. Okay, here is -4. Okay. So this is what we are going to get. So this is the table. Once we know the table, we can now go ahead and plot the graph. Once we know the table, we can go ahead and plot the graph. We are given the scale. We have to use the scale of 2 centimeter to 1 unit on x and 2 centimeter to 2 units on y. So let's you will not get, you will be given a graph. A graph will be provided in the question, in the answer booklet. So look at this very well though. In case of x axis, it's -3 to -3. So, but in case of y, we look at the value. Which one has the positive? The highest value is positive here. 17 is we have 17 as positive, then -4 as negative. So that simply means that if this is a y-axis, if this is a y-axis, your x-axis will move closer to the negative part. If this is a y-axis, if this is the y-axis, if this is the y-axis, then it is this table that will tell us how to locate. It's the table that will tell us what to do. If this is y, okay. In case of y, the positive value is more than the negative. So we can bring it down like this. Okay, we say this is minus x-axis. This is x-axis. That one is evenly distributed. But in case of y, this is minus y-axis. So we along x-axis is 1 centimeter. We have to use 1 centimeter, 2 centimeter to represent 1 unit. So here will be -1, -2, -3. 1, 2, 3. But in case of x-axis, 2 centimeter to 2 units. Here we only have -2, -4. That's the only negative that we have here. The highest is -4. But in the positive, we have 17. So we are going to have 2, 4, 6, 8, 10, 12. We have a long way to go. 12. We have 14, 16, 18. So we can stop at that because the highest is 17. So we can stop at that. Then we now impute the value. When x is -3, what is y? 17. When x is -3, you trace it to where y is 17. You know, this is not a graph, I'm just sketching. In a graph, you can do the normal tracing. When x is -2, y is 6. -2, trace it to where y is 6. Okay? You trace it to where y is 6. When x is -1, y is -1. Okay, that is fine. -1, -1. Here, -1. Look, it will be somewhere around here. Then when x is 0, y is -4. X is 0 along the y-axis. X is 0 along the y-axis. Y is 0 along the x-axis. When x is 1, y is -3. When x is 1, y is -3. Okay. So when x is 2, y is 2. When x is 2, y is 2. Okay. Then when x is 3, y is 11. 3. Let's place it to 11. 11 is somewhere here. So you realize that this graph is curve-like. So the graph of quadratic equation is curve-like. It's a form of a curve. But it can either be this or this, depending on the coefficient of s squared. So we can, at times they ask us to use group. But me, I believe in freehand sketch. Just make sure you are consistent. You can use your hand to join everything. Just make sure you are consistent. If you use group, at times people doesn't get it though. Just make sure you are consistent. You can use your hand to join everything. You just say graph of y is equal to 2x squared minus x minus 4. So we have been able to plot that graph now. We have been able to plot the graph. So that's the graph on the board. We have been able to plot the graph on the board. So that is the big part of the question. See now, Roman figure 1. We want to use this graph to find the root of the equation. So what will be the root of the equation? The root of the equation is all the value of y when y is equal to 0 is the root of the equation. The root of the equation is when y is equal to 0. So we trace it out. The root of the equation is when y is equal to 0. Because this is y. So y will be equal to 0 along x-axis. So this is the root of the equation. The root of the equation is when y. The root of the equation, C Roman figure 1, is when y is equal to 0. That's the equation. What we have 2x squared minus x minus 4 equal to 0. That's the root of the equation. So if this is graph, just trace it. along this x-axis. Y is equal to 0 along x-axis. So here it will be around s is equal to minus, let's say maybe minus 1.2 or maybe 1.5. That will be the root of the equation. We are not using, I'm not using the graph now. I only sketch. But when you use the graph, you can get the root of the equation. You should be able to get the root of the equation directly. Then Roman figure 2, we want to also use the graph. We want to use the graph to find the value of x for which y increases as s increases. To find the value of x for which y increases and s increases. So what do we do there? So what do we do there? We want to find the value of x. We may not be able to this question, I may not be able to get it correctly because this I can't locate any point here. We don't have graph book here. This is just a sketch. I don't have graph book. It's not a sketch. But if you're on your graph, we'll be able to trace out what we are talking about. You will be able to trace it out. But here it's just a sketch. You know, a graph has small blocks that will be able to trace out. But here now is a problem. I may not be able to do that. Then the third one is to find the minimum point of y. We want to find the minimum point of y. The minimum point of y is this peak here. Is the peak here. You trace it. You trace the minimum point here. Is the peak here. Is around minus 4 point something. So the minimum point of y is the peak there. So we can trace that. And if you look at that critically, the minimum point of y will be around minus 4 or maybe something around minus plus or minus 4.1 or something. So this is not a graph, so I may not be able to pinpoint some things properly. But at least we know how to generate the table now. So the table is just we will only be given x and y. So just list out what you are given. That equation, that y is equal to so. List everything out. Substitute for x for each of the table. Then you'll be able to get what you are given. Then on your graph, don't forget, if you have to plot any graph, the graph must have title. The graph must have title. Graph of y is equal to 2x squared minus x minus 4. There must be title on your graph. There must be scale on your graph. Scale on, depending on the question. In this case now, we are given different scale. So you must abide. You must use the scale that we are given here. But in some graph, you'll be allowed to use the scale. Once you look at your table, you can generate the scale. You know that in case of x, it's uniform. It's from -3 to 3. So you know that you're going to divide your graph into 3 equal halves along the y-axis. But what if the value of x ranges from -2 to 5? You know that the value of your y, we are going to move it closer to the left-hand side. So it is the table. It is the table, the value of x and y on the table, that will actually determine how you position your graph on the graph book. We don't have any formula for that. It is the table. You look at the highest value of x, you look at the lowest value of x, look at the highest value of y, you look at the lowest value of y, then you should be able to position your table. So that's what we do. That's what we're going to do when you are given a question on that graph, on that quadratic graph. This is quadratic graph. So this quadratic graph. In quadratic graph is curved line. At times you will be given the two graphs. You'll be given quadratic and linear graph. It's possible to also have question of that nature. So if you are given a question of that nature, then okay, I have one here. The question says that this is YX 2001, question 6. The question says that you should draw the table of values for the relation. The first one is quadratic graph. Y is equal to s squared. Okay? For the interval -3 to 4. That's value of x. Now they're using the scale of 2 centimeters to 1 unit on x axis and 2 centimeters to 2 units on y axis. Draw the graph of y is equal to s squared. Now I've got 2. We have to draw the graph of y is equal to 2x plus 3. Use your graph to find the root of the equation, then the gradient of y squared at s is equal to 2. So this one also, you can have something of this nature. We can have something of this nature. There are some that you will be given the graph. You will only be required to trace out the value. So in this second question, let's attempt the second question. Then we go to bearing. Let's attempt this second question. Then once we attempt this second question, we can go to bearing. So this is the question. I'm about to write the question on the board now. This is the question. Let me write the question on the board so that we solve this. After this, I'll move to trigonometrical graph that involves sine, cosine, and tangent. Okay, so you can have question on that graph. Just note that at least you have one question. At least compulsory to have question on that graph. You surely have question on that graph, and it can be cumulative or give cumulative frequency curve. So you can have graph. So let's take this question. This other question is a bit unique. So the question says that we should draw the graph of the relation y is equal to s squared. We want to draw the graph of y is equal to s squared. That's interesting. We want to draw the graph of y. Graph of y is equal to s squared. This is what the A part of the question says. Draw the graph of this for the interval. This is interval minus 3 less than equal to s less than equal to 4. That's what we have to do. Okay. Then we have to use the scale of. Okay, no problem. Okay. So the first thing is that I will generate the table. How do I generate the table? I will list out the value of x. S ranges from minus 3 to 4. S is from 3 to 4. So I'm going to list out the value of x, then I'll get the value of y. S ranges from minus 3 to 4. I will have minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. That's what I'm going to get. Then I will go for s squared. Then I'll get the value for y. That is all. That's all that I'm going to do here. That is all that I'm going to do. Because in this case, the value of y is just s squared. The value of y is s squared. Though the value of y is s squared. So we are not given the table. We are not generating the table. S squared here will be 9. S squared here will be 4. Here will be 1, 0, 1, 4, 9, 16. Then what is y? Y is equal to s squared. So this will also be y. Y is equal to s squared. Y is equal to s squared. So y will be 9, 4, 1, 0, 1, 4, 9, 16. That is y. Then in the question also, we have to draw the graph of another one. It's when we have y to be equal to linear 2x plus 3 for the same value. So I will do. We are going to have two tables here. I will get another table. X same value. X same value. Minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. So I'll get another table. Then I have a portion for 2x. I have a portion for 3 plus 3. Then I'll get portion for y. So in this case, we have two graphs, linear and quadratic. So 2x here will be minus 6, minus 4, minus 2, 0, 2, 4, 6, 8. This is the constant, plus 3. Just write that throughout. So what is y? Y is 2x plus 3. So for me to get the y on that linear graph, I will just add these two together. I will add the two together. So I'll just add these two together. I'll just add the two together. So if I add the two together, I'm going to get minus 3 here. I will have minus 1 here. I will have 1, 3, 5, 7, 9, 11. That's what I'm going to get. That is what I'm going to get. That's what I'm going to get there. Then I can now go and plot my graph. I can go ahead and plot the graph. Since I can go ahead and plot the graph, since I have the two tables, so I can go ahead and plot the graph. So I can go ahead and plot the graph. So what is the scale? We are given the scale to use. So if you are given the scale to use, you can't use your own scale. We have to use the scale of 2 centimeter to 1 unit on X and 2 centimeter to 2 units on Y. So, but in this case now, the negative is less than the positive along the X axis. So I'm going to have something of this nature. The graph will be, then I will have something of this nature. I'm going to get something of that nature. No, it should be more of X positive to negative. Here is 0, minus 1, minus 2, minus 3. I will have 1, 2, 3, 4. This positive X. Then along the Y, 2 centimeter to 2 units. Along the Y axis, 2, 4, 6, 8, 10, 12, 14, 16. I think 16 is the highest. Okay, 16 is the highest. So I want to plot the two graphs. I'll start with the quadratic graph, the first one. When X is minus 3, when X is minus 3, Y is 9. When X is minus 3, Y is 9. When X is minus 2, Y is 4. Minus 2, 4. When X is minus 1, Y is 1. 1. When X is 0, Y is 0. That's the origin. When X is 1, Y is 1. X is 1, Y is 1. When X is 2, Y is 4. When X is 2, Y is 4. Okay. When X is 3, Y is 9. 3, 9. Then when X is 4, Y is 16. So this is the quadratic graph. So I can join the graph. I'll just join. This is the graph. So this is graph of y is equal to s squared. This graph of y is equal to s squared. Okay, I've been able to plot the first graph. Graph of y is equal to s squared. So I'll go to the linear graph, the second one. When s is minus 3, when s is minus 3, y is minus 3. When s is minus 3, here. Y, when s is minus 3, y is minus 3. Okay. When s is minus 2, y is minus 1. When s is minus 2, no, when s is minus 3, y is minus 3. X minus 3, y minus 3. Something around this nature. When s is minus 2, minus 2, minus 1. When s is minus 2, minus 1, something. When s is minus 1, 1, minus 1, 1. Okay. When s is 0, y is 3. When s is 0, y is 3. When s is 1, y is 5. When s is 1, y is 5. When s is 2, y is 7. 2, 2, 7. When s is 3, y is 9. 3, 9. Then when s is 4, y is 11. 4. When s is 4, y is 11. So you realize that this other one, this will be a straight line. If you plot it using graph, it must be a straight line because this is a linear equation. It's a linear curve, so it must be a straight line. So this second one is the graph of y is equal to 2x plus 3. So we have been able to plot the two graphs. So the question now says use your graph to find the root of the equation. That's the first question. We have to use a graph to find the root of the equation. We use a graph to find the root of the equation. Okay. So we use a graph to find the root of the equation. Then the next one. So the root of the equation will be, the root of the equation here will be their meeting point, where the linear and the quadratic meet. See Roman figure 1. See Roman figure 1. The root of equation will be their meeting point here. It will be -1, then this other one is 3. And 3, that will be the root of the equation. The first one that we did, the root of the equation is along the x-axis. But here, the root of equation will be where the linear graph cuts across the quadratic graph. That will be the root of the equation in this case. So that will be the root of the equation in this case. Okay? So let's take notes. That's the root of the equation. Then we have to find the gradient. The gradient of y is equal to x squared at s equal to -2. We want to find the gradient at s is equal to -2. So, of course, we know the meaning of gradient. Gradient is slope. So gradient is slope. We want to find the gradient at when x at s equal to -2. We know the meaning of gradient. Gradient is actually called slope. So gradient is actually called slope. So what do we do there? Gradient is slope. So at s equal to 2, we look for the value of y2, y1 at s equal to 2. So at s equal to 2, that's what you get here. So we want to find the gradient. Gradient is slope. So gradient by formula, gradient will be y2 minus y1 all over x2 minus x1. That's what we are going to use. I don't have graph board. How do you mean I have graph board? We are going to see everything clearly. But of course, it's still fine. At least we can sketch something on the board. We can sketch something so at least we were able to see something. So the gradient at s equal to -2. If you look at that very, very clearly. So that gradient at s equal to 2. We are going to trace it at s equal to 2. We trace it to what we have here. So we look for y2, y1, x2, x1. That's how to get the gradient. So if you do that on your graph, you should be able to get the gradient. So please check on your graph. You should be able to get the gradient on your graph. Okay? Locate that on your graph. This is just a sketch. I cannot get actual value here. It's a sketch. So let's talk about the graph of sine and cosine. It is possible that y will not bring question on this. It is possible for y to bring question on graph of sine and cosine. Graph of sine and cosine. So graph of sine and cosine. We also have graph like that. So in this case, we'll be dealing with angle. We'll be dealing with angle. But before I will teach that, I'll just do a general recap of this. So sine, we have sine curve and we have cosine curve. Sine curve is like this. If this is 0, -1 plus 1. So when we have sine curve starts from the origin. This is sine curve. This is sine curve. Then we have cosine curve. This is 0, -1, 1. Cosine is like this. This one does not start from the origin. So the difference between sine and cosine is phase angle. That is, if I decide to shift the origin here, from here to this point, I'm going to get cosine. I'll get cosine. That is why sine 30 is equal to cos 60. When you look at the trigonometric table, sine 30 is 0.5, cos 60 is 0.5. Sine 60 is equal to cos 30. Because the difference between sine and cosine is curve, is just a phase angle. But tan has truncation. In case of a tan, we hardly talk about tan curve. There's no linkage. It has truncation. So tan has truncation. So tan 90 is undefined. Tan is not the same as tan. So most of the time when we are under trigonometric curve, we only talk about sine and cosine curve. And we must be familiar with the fundamental identity. Apart from the fundamental identity, all this we have these special angles. You should be able to know their values offhand. Okay, if you want to solve any problem, under the graph of sine and cosine. So let's take note. If it's possible, this year, why can I decide to bring something like this? Graph of sine and cosine. We can have question under graph of sine and cosine. They have done it in the past and they can still do it. So let me just pick one or two questions. Let's discuss one or two questions under the graph of sine and cosine before we now move to bearing and distance. Let me look for current question. So you can have question in any form. Okay. Okay, we have question here. 2022, question 9, theory part. That year they didn't bring question on quadratic graph. The question they brought that year is trigonometric graph. That year is trigonometric graph. So let's listen to the other question. We have question 12A. It's question 2022, question 9. We have copy and complete the table of values for y is equal to 3 sine x plus 7 cos x. For is 0 less than equal to x less than equal to 180. Look at, in case of quadratic and linear graph, the value of x is minus 3 less than equal to x less than equal to something like this. But since we are in trigonometrical ratio now, we are in trig graph now, we'll be talking about angles. Our range of value will be in form of angles. Is that again? Our range of values will be in form of angles. Our range of values will be in form of angles. So this trig graph, okay, and this is the table. We are given the table as x. We have this table is 0 degrees. Okay, we have 20 degrees, 40 degrees, 60 degrees. In this case, we must note the value. This might be a bit tedious if you don't have scientific calculator. If we don't have scientific calculator, we might not be able to do it. Please let me pick question that has to do with 30, 60, 90. That I know the value of hand. Okay, all these sine 20, sine 40, they are not special angles, so I don't know the value of hand. If you are given this, you'll be required to use calculator or graph. We need to go and check the angle at the back of your four-figure table. Okay, is that taken? So please let me pick question. Let me pick question that has to do with 30, 60, 90, so I can generate those values of hand. But in this case, I may not be able to generate all this sine 20, sine 40 of hand. I will need to use calculator or four-figure table, and that will take a lot of time. So let me pick the one that has to do with 30, 60. So I've gotten one here. This is 2000. This is 2014, question 7. Then we have copy and complete the relation y. Here y is equal to, here we are given y to be equal to 2 sine x plus 1. 2 sine x plus 1. That's what we have. And this is the table. X is equal to 0 degrees. We have 30. We have 60 degrees. So I can generate the value of this one offhand. We have 90 degrees. We have 120. We have 150. We have 180. We have 210. We have 240. Then 270. So these are the values that we are given. Then we have value of y. The value of y, we are only given this to be 1.0. The value of y, we are given this to be 2.7. We have this to be 0.0. Then we have minus 0.7. So this is what we are given. We are given what you have on the board. So B part of the question answer, using a scale of 2 centimeters to 30 degrees on tip x axis and 2 centimeters to unit on y axis. Draw the graph of this. When we finish the table, we are going to draw the graph. for 0 degree less than equal to x less than equal to 270. Use the graph to find the value of x for which sin x equal to 1/4. Okay, so this is what we are asked to do. Before we can do anything, we must first copy. Before we can plot the graph, we must copy and complete that table. So if we want to complete this table now, what do? I'll just do an extension. Let me move to this side so that I'll be able to plot the graph along that side. So if I want to do that, I will need to write out everything. Without that, I cannot get anything. So can you see this? Okay, this x. Let me move towards this side. So here will be x. Here will be x. But let me come down. Here will be x. Then I will have 0, 30, 60, 90, 120, 150, 180, 210, 240, then 270. That's what I'm going to have. I will have this. Then what is y? I have 2. No, I'll first have sin x. Sin x. Before I will have 2 sin x. I will have column for 2 sin x. Then plus 1. Plus 1. So my y will now be the final answer. Y will be the final answer. Okay? We have to do it stepwise. If you don't want to make mistake. If you don't want to make mistake, we have to follow this. We have to do this. So let's get value for sin x. Let's get value for 2 sin x. We get value for plus 1. Then the value of y will come out naturally. What is sin 0? Sin 0 is 0. Sin 30 is 0.5. Sin 60 is 0.866. Sin 90. Sin 90 is 1. Okay. Sin 90 is 1. Sin second quadrant is 180 minus theta. So sin cast. Okay, sin is still positive at the second quadrant. Sin 120 is the same thing as sin 60. So this will be 0.866. Sin 150 is the same thing as sin 30 is 0.5. Sin 180. Sin 180. Sin 180 will be negative, right? Sin 180. Sin 180 is 0. Sin 180 is 0. Sin 210 should be minus 0.5. Sin 210 will be minus. Sin 240. Sin 240 will be minus. Let me check the curve. 180. Sin 270 is minus 1. Here should be minus 1. 240 should be. Sin 240 should be minus sin 30. That will be minus 0.5. Minus 8.66. 8.66. Okay. So 2 times 0. 2 times 0 will be 0. 2 times 0.5 will be 1. 2 times this 0.866. 2 times 6 12. 2 times 6 times 8 70. So that would be 1.7. 1.73. Then 2 times 1. This is 2. When you multiply this is 1.73. Here is 1. Here is 0. Here is minus 1.73. Here is minus 1. Here is minus 2. It's minus 2. Okay. Then plus 1 is common. Plus 1 is common. Plus 1 is common. So if I add everything together here, I'm going to get 1. If I add everything together here, I will have 2.5. This one, if I add everything together, this 2.7. Another is 0.86. This will be 2.6. or 2.5 and 2.6. No, this is 2.6. Here I'm going to get 4. Here I'm going to have 2.6. Here I'm going to have 2.5. Here I'm going to have 1. So maybe this is approximately 2.7. This is 2.7. Here I'm going to have 1. Here I'm going to have minus, this is 2. Minus 2.7. This is minus 1.7. Here I'm going to have minus 0.5. Then here I'm going to have 2. Okay, that's the table. So we have been able to plot the table. We have been able to plot that table. So that's 240 is minus, that 240 is minus 0.7. 240. So it shows us here will be minus 8.6, minus 8.66. Here will be minus 1.7. So here will be minus 0.7. Here will be minus 0.5. Here will be minus 1. Here will be 0. Here will be 0. Here is minus 2. That's what you are going to get. Okay? That's what you are going to get. So we have that. So we want to draw the graph now. 2 centimeters to 30 degrees on X and 2 centimeters to 1 minute on Y. So let's plot the graph. So we are going to plot the graph now. So how do we plot the graph? This graph will be something of this nature. Positive is 4, the highest here is 4. For negative is 2. So I'm going to have something of this nature. I'll start from here. 0. I will have 30, 60, 90, 120, 150, 180, 210, 240, 270. So then along the axis, what is the scale are we supposed to use? 2 centimeters to 30, then 2 centimeters to 1 unit. Okay. I'm going to have minus 1. Minus, I'll have 1, 2, 3, 4. That's what I'm going to get. That's what I'm going to get there. So I'm now input the value. When x is equal to 0 degree, y is 1. X is 0, y is 1. When x is 30, 2.5. 30, 2.5. When x is 60, 2.7. X is 60, 2.7. When x is 90, is 4. When x is 90, here is 4. So when x is 120, is 2.7. 120, 2.7. When x is 150, is 2.5. When x is 150, 2.5. When x is 180, is 1. 180, 1. When x is 210, is 0. Okay. When x is 240, it is 0.7 minus 0.7. Then when x is 270, is minus 2. It's minus 2. So here is minus 2. So you can join the curve. So we are going to, it's because you are going to get something of like something of this here. So graph of y is equal to 2 sine x plus 1. Just take it. So you're going to get something curve-like like that. You're going to get something curve-like nature like that. That's what you're going to get. You're going to get something curve-like what you have on the board. So you can then use what you have on the board to solve some of the questions that will be required. Okay. So here is 1. Here should be -1. Here should be -1. Here should be -1. Okay. So the next question now is the next question that we are supposed to do is we have to use the graph to find the value of x for which sine x is equal to 1/4. Sine x equals 1/4. Here at the origin so sine x is equal to -1. Sine x is equal to -half. So what do we do on the graph? You can locate that on the graph. I don't have graph board. I need to get graph board. I don't have graph board, but you can locate that on the graph. So you can locate that on the graph when sine x is equal to 1/4. So you can locate it on the graph. It will be around 15 degrees and 165 degrees. So please, we can locate that on the graph. So because of our time, I will just go straight to bearing and distance. I will go straight, but of course, you know that you can have something of this nature. But it is very easy when you have special angles. That is 60. But if you don't have special angles, I want to believe that the use of calculator is allowed. They allow you to use calculator this time around. So if the use of calculator is allowed, just press your calculator. Even if it's sine 20, just say sine 20, sine 40, sine 60, then 2 times sine 20. You can use calculator to generate all these tables. Okay? But without the table in any graph, you cannot solve. Even if it is commutative frequency graph, you cannot solve it. Without the use of calculator, you cannot solve anything. So the calculator is important. Table is important. Without table, you cannot solve any problem on that graph. Table is very important for us to be able to solve questions on that graph. So let's take note. Let's take note of that. So let me do a recap on bearing and distance. Bearing and distance. Bearing and distance. What is bearing? For the geography students, you recall that we have 4 cardinal points. 4 cardinal points when we talk about north, south, west, and east. And at the center here, it is 90 degrees. So from north to east is 90, is 360. East to south, another 90. South to west, 90. West to north, 90. Okay? So we can talk about, if this midpoint, we can talk about northeast. We can talk about southeast. The naming will start from the north, either north or south. We can talk about southwest. We can talk about northwest. So if you want to do the naming will strictly start from either north or south. Okay? So when we talk about bearing, when we take a bearing, it has to do with direction, then it's a function of distance. So we can't talk about bearing without distance. So that's why we call it bearing and distance. So basically, there are 2 types of bearing. There are 2 types of bearing. We have what we call 3-digit bearing. 3-digit bearing. Example of 3-digit bearing is when you have 45 degrees, 120 degrees, 239 degrees. These are 3-digit bearing. Then for 3-digit bearing, if you want to indicate on 3-digit bearing, it's a must for you to start from the North Pole. You must start from north. This is 45 degrees. This is 45 degrees. You must start from the north. When you have 3-digit bearing, 120, this is 90, you add 20 to it. This is 120 degrees. Okay. For 239, this is 90, 180, 239 will be somewhere around there. Okay. So when you have 3-digit bearing, you must start from the north. Start from the north pole. It's a must to start from the north pole. Okay. It's a must to start from the north pole. Then the second type of bearing that we have is compass bearing. Compass, we have 3-digit bearing. 3-digit bearing. That's the first one. And this example. The second one, we have compass. In case of compass bearing, you either start from the north or south. Okay. In case of compass bearing, you either start from the north or south. Okay. That's where we talk about north 30 degrees east, south 25 degrees west. Okay. North 30 degrees east, you start from north, you move towards east, 30 degrees. Okay. So north 30 degrees is same thing as 30 degrees when we have compass bearing. Then south 25 degrees west. You start from south, you move towards west. This is east. 25 degrees towards west. So south 25 degrees west is same thing as if you want to convert this to compass bearing now. You start from here 90, 90, 180. It's same thing as 215. No, 205 degrees. When you convert south 25 degrees west to compass bearing, we are going to have it to be 205 degrees. Okay. There are two types of bearing. Compass bearing, a 3-digit bearing. That's under 3-digit bearing is a must to start from the north pole. But when we have compass bearing, you either start from the north or from the south. You can even have north 20 degrees west. So if the question is not 20 degrees west, you start from north, you move 20 degrees towards west. Okay. So not 20 degrees west, same thing as 340 degrees when you convert it to compass bearing. Okay. There is a link and relationship between the two. So that is what we are going to have. Okay. So you must know this. This is the first thing that you know. You must know under compass bearing. Another thing that you must know is when you have sine rule. You must know how to apply sine rule and cosine rule before we talk about bearing. If you don't know how to apply sine rule and cosine rule, you are going to have problem under bearing and distance. So on my, I have videos on sine rule, cosine rule, bearing and distance. I have more than 320 videos on my YouTube channel. Most of the concepts, they are secondary school concepts that can be beneficial for you guys. So when we talk about sine rule, without sine rule, you cannot solve problem under sine and cosine rule. You can't solve problem under bearing. When we talk about sine rule simply means A, in a triangle. If this is A, angle B, angle C, this side will be B, here will be A, and here will be C. If the triangle is not the right angle triangle, of course, we cannot apply Pythagoras theorem. If you are sure that the triangle is not the right angle triangle, you cannot apply Pythagoras theorem. So you can only apply either sine rule or cosine rule. Okay, and there are conditions that we consider before we can use sine rule and cosine rule. You can check my video. Sine rule says that when you have A all over sine A is equal to B all over sine B, which is equal to C all over sine C. Capital letter we use it for angle, small letter for size. Okay, this is sine rule. This is sine rule. We also have cosine rule. These are some of the concepts you must know before we talk about bearing. Without all this, you have problem. You will not be able to solve problem without bearing. So under cosine rule, when we have A squared, it's same thing as B squared plus C squared minus 2BC cos A. If you are looking for the small side here, so if you want to look for B, we are going to change this to A plus C squared minus 2AC cos B. Then if it is small c, it is A squared plus B squared minus 2AB cos C. So this is cosine rule and this is sine rule. So you must know cosine rule and sine rule. You must know how to apply them, when to apply them before you can solve problem under bearing. If you are given all the three sides without angle, you go ahead and apply cosine rule. If you are given two sides and the included angle, two sides and the included angle, you go ahead and use cosine rule. Apart from the two, then you are supposed to you are to apply sine rule. Condition for this cosine rule is that if you are given two sides and the included angle, you use cosine rule. If you are given all the three sides without any angle, you use cosine rule. But apart from that, those two conditions, any other problem you have under bearing, you are expected to use sine rule. Okay, this is sine rule, this is cosine rule. Then I can now introduce question under bearing. Since I've done a recap on sine rule, on cosine rule, and I've also talked about different type of bearing, compass bearing and 3-digit bearing. Then we can go ahead and take questions under bearing. Okay, we can take questions under bearing. Can go ahead and take questions under bearing. So let me start with this question. There's this question here. There's this question here that says that the diagram shows the position of 3 points x, y, z. This diagram. I'm going to sketch the diagram on the board. This is the diagram. This is x, y, and z. Okay. X, y, and z on an horizontal plane. Okay. The bearing of y from x, the bearing of y from x is 312. Bearing of x from y is 312. Yeah, so here is 312. Bearing of y from x is 312. So here is 312 degrees. Okay. And that of y from z is 22. Y from z is 22. It's 22 degrees. Okay. It's 22 degrees. If xy is 32 kilometers, xy here is 32 kilometers. Okay. If and zy is 50 kilometers. 50 kilometers. Okay. Calculate correct to 1 dp decimal place xz. Okay. We want to find xz. We have to find xz. Okay. Then apart from xz, the bearing of z from x, the bearing of z from x. Okay. The bearing of x from z. So those are the two questions that we want to find. We have to calculate. We want to calculate xz, side xz. They want to calculate the bearing of. We want to calculate the bearing of z from x. Also, I also have videos on bearing of where I apply sine rule and cosine rule. So if time permits, you can check my videos on bearing. So it's well I explained better there, and you're going to understand this. Okay, so that is what we have. Now look at, if this is 312, look at what you do. This is north and this is south. Here is north, here is south, north, south. Okay, the bearing of y from x is 312. So it's going to move from here 312. So what is the remaining angle here? The remaining angle here will be 48. Okay, the remaining angle here will be 48. Why is it 48? Angle at the point is 360. Then because this is north, west, east, south, this 48 is alternate to this angle. This one will be 48 degrees. Alternate angle are equal. They alternate each other. Look at this place is 22. North, east, west, south. This 22 is also alternate to this place. So here will also be 22 degrees. If you add the two together, the angle here will be 70 degrees. So the angle between them is 70 degrees. So for me to be able to know this side xz, I'm going to apply cosine formula. Because for cosine formula, if I apply cosine formula here, I'm given two sides and the included angle. If you are given two sides and the included angle, the condition says that you should apply cosine formula. If you are given all the three sides without any angle, you apply cosine formula. Okay. Apart from that, every other question, then you go ahead and apply sine formula. So I'm going to apply cosine formula here. And if I do that, in this case now, this side xz, let me call side xz that we're looking for as y. Because let me call this small y. Z here, this 32 will be z, small z, and x will be 50. So we are looking for small y. Then I will say using cosine rule. We are looking for y small y squared will equal to x squared plus z squared minus 2xz cos y. So y squared, that's what we are looking for. X squared is 50 squared plus 32 squared minus 2 times 50 times 32 cos 70 degrees. So here I'm going to have 250,000 plus, what is 32 squared? What is 32 squared? No, 50. 50 is 25. 50 is 25 plus 32 squared. 32 squared is going to give us 1024 minus this is 100. 100 minus 320. So if you check cos 70 will give us 0.3. It's going to give us 0.340, 3420. Then from here, I'm going to have 3024. Okay, I will have 3024. This is 25. I will have 3524 minus, if I use 320 to multiply 0.24, if I use 3200 to multiply that, I'm going to have 1094.5. Okay, so if I do the subtraction, I'm going to have 24. I will have 2429. 2430. That's what I'm going to have. Then y squared. So y will now be square root of 2430. So if I take the square root will give me approximately 49.3 kilometers. So invariably, side xz, which is equal to y, is approximately 49 kilometers. So that's approximately 49 kilometers. That's what we are going to get. Then another question is that we should find the bearing. We should find the bearing of, we are asked to find the bearing of z from x. So how do I get the bearing of z from x? The bearing of z from x. For me to be able to get the bearing of z from x, I must know this angle. Let's call it alpha. If I know this angle, I'll remove it from 320. Then that's going to give me the bearing of z from x. So without that, there's nothing I can do. If I don't know that angle alpha, I cannot know. Or let me call that angle. Let me call that angle theta. Without knowing that angle theta, I cannot know the bearing of z from x. For me to know the bearing of z from x, we start from here. I know this is 90, 90, but I don't know this angle. But once I know this angle here, I'll know 1, 2. That will give me the bearing of z from x. So how do I know this angle theta? So I know this space now to be 49.3. So if I want to know this, I know this, I'm looking for this. I know this side. I know this, I know this. I can apply sine rule. I'll say using sine rule. Using sine rule. Okay. I'll say using sine rule, I'll say 50 all over sine theta, the angle I'm looking for, will be equal to 49.3 all over sine 70 degrees. So if I cross multiply, sine theta will be equal to 50 sine 70 degrees all over 49.3. So what is sine 70 degrees? What is sine 70 degrees? Sine 70 degrees is 0.9397. So I'm going to get 50 multiplied by 0.93 multiplied by 0.9397 divided by 49.3. And if I do that, I'm going to get 0.9532. So sine theta is equal to 0.9532. So if sine theta is equal to 0.9532, Then what do I do? What I'm expected to do is that I will say theta is equal to arc sine is 0.9532. Of course, arc sine, you can check this from a calculator, from your first dot table. Or if you have a calculator, just press shift sine, that will give you arc sine. Then theta is going to be approximately, when we check that value, it will be approximately 72 degrees. That is what the value of theta will give us. So if I know that from here to here is 72 degrees, okay, if I know that from here to here is 72 degrees, then what I can do is that for me to be able to find the bearing of z from x, I will now say that the bearing of z from x will now be equal to the 3112 minus 72, and that will be 240. So the bearing of x from z will be 340. That is what you are going to get. You are going to get that bearing to be 340. That's what you are going to get. Okay. So we can have so many questions on bearing, but there's this concept I want to talk about briefly before we close the class. It is called algebraic fraction. No, at times it is common in WAEC, where we have to find, the question will say, what value of x will make this equation undefined? That is, it is common. You can have it in object, you can have it in theory under algebraic fraction. Algebraic fraction. So the question will say, what value of x will make a particular fraction undefined? We do have it on yearly basis. So I want us to talk about that. Let's quickly talk about algebraic fraction. Algebraic fraction. And some of us, if we ask to simplify, at times some of us doesn't know what to do. We don't know what to do. So let's do about 2 or 3 examples on that. Okay, let's do about 2 or 3 examples on that before we call it a day. I want to look for a question that talks about what value of x, or what is value of x that will make that a particular expression undefined. Okay, for instance, if you have something like this, 2s cubed, my pen is not right. If you have something like this, if you have something of this nature, 2s cubed plus 3s plus 4 all over s minus 4. So you can be asked that what value of x, algebraic fraction, what value of x will make this fraction undefined? What value of x? They can say simplify. They can at times they first tell you to simplify the expression. After the simplification, the big part of the question will now be what value of x will make that expression undefined. What they are trying to ask invariably is that for this expression, what we have on the board to be undefined, the denominator must be equal to 0. That is, if you say 0 divided by 5 is 0. But if you say 5 divided by 0, it is undefined. So please let's note. When you press a calculator, say 0 divided by 5 is 0. But if you say 5 divided by anything, once there is 0 at the denominator, that expression will be undefined. So if you have this type of question, and the question says that what value of x will make this expression undefined, just equate the denominator equal to 0. Say x minus 4 equal to 0. Then x is equal to 4. So when x is equal to 4, this particular expression will be undefined. Because when x is equal to 4, we have 4 minus 4. 4 minus 4 equal to 0. And as long as you have 0 at the denominator, that expression will be undefined. So if the question says what value of x will make that expression undefined, if you have this type of question, just make sure that you equate the denominator equal to 0. And that will actually make that expression undefined. So please let's take note. Oh, there's a question here that why doing the tree graph? Is there a specific DP it must have? decimal point. And no, it depends. It depends. At times they will say like the second one, the one I treated. The DP is 1. We are asked to convert it to 1 DP. So if it's 1 DP, you can have something like 2.3. But if you are asked to no, just look at the table. Look at the table that is given. In the table, if they decide to approximate to 1 DP, do everything in 1 DP. In the table, if you have at least if the table has about 10, there will be 2. They will give us at least 2. Just to confirm if your question that. So in the table, if you have 2.33, you should know that you are going to express this as 2 decimal places. Okay, but if like the example that we consider is only 1 DP. Okay, just follow the trend of the table. The table should be able to, even if they didn't tell us, the table should be able to indicate that. Just check the table and follow the trend. Okay, check the table, either linear, quadratic, or what have you. If once you look at the table, in the table they will give you the value of x, the value of y. The table can be, the column might be up to 12. At least they will give you at least 2. Maybe in the table you have something like 2.35, I find 3. You should know that all your solution, all your the value of your y must be approximated to 2 DP. Okay, well, if it is 1 DP, just follow the trend of the table that was given. So follow the trend of the table that was given. Okay, that is that. Follow the trend of the table that was given. Okay, so that is that. Okay, somebody said, okay, let's take one more question on bearing. It is almost 6 o'clock. Let's take one more question on bearing. Then we will rest. So for those that still want to write JAMB, post UTME, we can actually organize lecture. Just subscribe. If you subscribe to my YouTube channel, then I can, once I send out notification, you'll be able to receive it. Then we'll be able to come together and discuss better. So you can send topics to me, the topics that you want us to consider. And some people still register for NECO. So we can make it maybe a weekly thing. So we can come up once in a while, maybe once in a week, to discuss any topic that you want us to discuss online. So location is no longer a barrier as a sort of internet. So we don't have any problem with location again. So let's take one more question on bearing before we take a leave. Okay. There's this question here, 2010 question 9. The question says that in the diagram, okay, I don't want us to take diagram. I want us to take the one that we are going to interpret. The one we are going to interpret ourselves. So that we interpret the question. Let me look for the question that we will interpret. Okay. There's one question here. 2021. I have one question here. 2021. 2021 question 10. 2021 question 10. There's a particular question here on bearing. 2021 question 10. Let me read the question before I will interpret, then we solve it together. 2021 question 10. The question says, 2021 question 10. The question says that a cottage is on a bearing of 200 degrees and 110 degrees from Dugbe and Manu's farm respectively. A cottage is on a bearing of 200 degrees and 110 degrees from Dugbe's and Manu's farm respectively. That's what the question says. It's on a bearing of 200 degrees and 110 degrees from Dugbe and Manu's farm respectively. I want to go through the question before we interpret it respectively. If Dugbe walked 5 kilometers and Manu 3 kilometers from the cottage to their farmland, find correct to two significant figures the distance between the two farms. Then be part of the question. The nearest distance, the nearest degree, the bearing of Manu's farm from Dugbe's. Okay, that is the question. That is the question. We have that a cottage we have that a cottage is on a bearing of 200 degrees and 110 degrees from Dupe and Manus farm, respectively. One is on 200 degrees, another one is from 110 degrees. Okay, so let's say this is the cottage. Let's say this is the cottage. Let's say this is the cottage. From this. So let's assume that this is the cottage. The cottage is here. So the cottage now, that's the cottage. The cottage from Dupe's farm is 200 degrees. And from Manus farm is 110. So this is the cottage. So let's assume that this is Dupe's farm. Let's call it D. This is the cottage, let's call it C. From here to here is 90, this is 180, then this is 200. So here is 200. That's what we do. From north, this is north, south, west, east. No, these are 3 digits bearing. So I said strictly you must start from the north. Then there's another farm here, Manus farm, that is 110. Okay, let's call this M. This is 90, 110. You locate the cottage here. This is 110 degrees. Okay, that's what we are going to get there. So we also given that if Dube walk 5 kilometers, from here to here is 5 kilometers, and this Manu is 3 kilometers. Okay, to that cottage, from the cottage to their farms respectively, find, correct the 2 significant figure, the distance between the 2 farms. We want to find the distance between these 2 farms. So let's denote the distance by small c. Here is D. This other one will be M. Okay, that's what we are going to get. That's what we are going to get. So if this is 210, here will be 20. Here will be 20. This space will be 20. Let me change this. This space will be 20. Here will be 20. Okay. Then if this is 110, here will be 70. That's what you are going to have 70. So of course, if you have the knowledge of alternate angle, corresponding angle, then we know that we will know what to do next. So if you have the knowledge of corresponding angle, then you know what to do next. So from there now, we'll know what to do. We can find angle C. From there, we can find angle C. So angle C will be what? Angle C is going to give us 90 degrees. This angle here is alternate to this small angle, which is 20 degrees. This angle is alternate to this angle, this is 70 degrees. Then the total of this will be 90 degrees. Okay. So if you want to find the distance from their farm, which is small c, it will be, we are going to apply cosine rule. Using cosine rule, we know that small c is equal to small d squared plus small m squared minus 2dm cos c. So in this case now, d is 3 squared plus 5 squared minus 2 times 3 times 5 cos 90 degrees. Cos 90 is 0. So here will be 9 plus 25 minus 2 times 3 times 5, 15. This is 30. Cos 90. What's the value of cos 90? Let me check. What's the value of cos 90? Cos 90 is 0. Cos 90 is, so here I'm going to have this. So c squared is equal to 34. So c is square root of 34. And that will be around 5 points. It's approximately 5 point something. C will be approximately 5 points, let's say 5.9 or 5.8. 5.9 kilometers. That will be their distance, the distance from the farm. Then the second one is to find, the second one we have to find the bearing. So that's the first one. That's the first part. That's the first part. Okay, I should write a bit more boldly. Okay. Okay, I will do that. I will do that. So let's look at the second part of the question. The second part of the question, where we are asked to find the second part of the question. So we are asked to find the bearing of Manus farm from Dope. Okay, the bearing of Manus from Dope. So for us to be able to find that bearing, we must know. For us to be able to find that bearing, then we must know this angle here. If we're able to find this angle here, that's when we can know the bearing. But without that, without this, we cannot know the bearing. So once I know this angle here, then I'll be able to find the bearing. So how do I know the angle here? I can use sine rule. Just go ahead and use sine rule. This over sine of this. I know this now. I'll say this over sine of this. Then once you know the angle, you just subtract it. Then you get your final answer. So I would love to stop here because of our time and because of where I'm going to. I wish all of you success. So if for those that will be preparing for post-UTME, maybe some that want to do NECO, you can just, if you can subscribe to my YouTube channel, just you can chat me up. I have my details there, my WhatsApp number. So just send the topic that you want us to discuss. So we can, once I send notification, you'll be able to get whenever I'm online, we can send notification that we can discuss. We can actually discuss maybe weekly or monthly, depending on the response from you guys. So thank you so much. God bless you. And I wish you success. Bye for now.